We've seen earlier in the year how forces can cause an acceleration, but the effects of a force will depend on the time that it's applied for. This is called impulse. Impulse is the product of the force and the time interval over which it is applied, and we measure it in Newton's seconds. So we can produce a certain impulse by applying a large force over a short period of time, or a small force over a proportionally longer period of time. So what effect does impulse have on an object's motion? The result of an impulse is a change in momentum. This is called the impulse momentum theorem. It says that impulse equals the change in momentum, or force times the time interval is equal to the mass times the change in velocity. The impulse momentum theorem is the underlying principle used in a variety of safety devices. Let's look at how that works in something like airbags. The easiest way to see this is graphically. An impulse is equal to the area under a graph of force versus time. Without an airbag, the driver is brought to rest over an extremely short time interval. This requires a very large force. An airbag increases the time interval, so a much smaller force is required. Both graphs show the same impulse and the same change in momentum, but increasing the time over which a change in momentum occurs minimizes the required force. This is why you quote-unquote give when catching something or bringing something to a stop. It's similar to the idea of flattening the curve we've heard related to the coronavirus. Let's take a look at a couple questions. Graph A is the force versus time graph for a hockey stick hitting a 160-gram puck. Graph B is the force versus time graph for a golf club hitting a 46-gram golf ball. Which force delivers the greater impulse? So remember, the impulse is equal to the area under the graph of force versus time. So if you compare the area of these two shapes, we'll figure out which one has the greater impulse. So we have 300 newtons times 5 milliseconds and 150 times 10. They both give us 1500 Newton milliseconds. So they have the same area, and as a result, both forces deliver the same impulse. A 10-gram rubber ball and a 10-gram clay ball are each thrown at the wall with equal speeds. The rubber ball bounces, the clay ball sticks. Which ball receives the greater impulse from the wall? So remember, impulse is equal to the change in momentum. So we need to look at, since the mass of the balls are the same, we have to look at the change in their velocity. So the ball that has the greater change in velocity has a greater change in momentum, and in turn has a greater impulse. We could eliminate D because it's clear that each ball does experience an impulse because each ball does show a change in their velocity. The rubber ball bounces back and the clay ball comes to a stop. And we can eliminate C because we know that they have different changes of velocity because one ball comes to a stop while the other ball bounces back. So it can't be C. So the ball that bounces back is going to have a greater change of velocity because not only does it have to stop, it has to stop and then move back with a greater speed versus just stopping something. It's like catching something and throwing it back out versus just catching it. Catching something and throwing it back out is going to require a greater impulse. So the rubber ball, the one that bounces, receives a greater impulse because it bounces.